next speaker is going to be Luke Blair with the USGS. He works at the Earthquake Science Center.
Thank you, and thank you, Kate. I can't express my appreciation enough for Kate and all her work administering her team with our collector and our USGS team. I'm really grateful to have her as a team member on this Clearinghouse data processing and data collection effort. Ridgecrest really upped our game as to data collection and dissemination after an earthquake. But it wasn't without some bumps and bruises, I should say. Being a holiday for us, we only really had one person available to process spatial data, and that was Ali Pickering. And we had to bring Dan Ponte out of retirement, and we're very grateful for his efforts as Dan was fresh off his experience with Napa data processing, and he had just released the data for Napa before this event, so he was an important addition. So the theme here is kind of doing more with less warm bodies. And so I want to show you a couple tools that were developed by myself and Dan Ponte and employed during this science response. And these are tools that I think will help us in the future to rapidly take data from field to publication data quality. You know, only USGS and CGS researchers had access to the ARC collector system for Ridgecrest, as Kate said, due to base security demands. So for various reasons, we can't expect everyone to collect with our collector or collect within our agreed upon schema. So we need to be able to handle what I call non-ARC collector data. And so over the course of this science response, we had thousands of observations that came in, derived from about 60 separate files, typically in the formats you see on the left here, and provided by about a dozen different public and private groups. And all these data need to be organized and processed to fit the Clearinghouse schema. And to do this, there are a multitude of tasks depending on the data content. For example, we need to create the GIS feature classes, and then photographs need to be extracted from like KMZs, and photographs need to be related to observations, and observations need to be verified for location accuracy and data issues such as duplicates and unit conversions in the measurements. And they all need to be resolved, and notes need to be parsed if there are measurements within notes. So we developed a couple tools ultimately after a few iterations over the data and trying to determine the correct workflow. We settled on basically processing the GIS data using a data logging tool into a GIS, where we can collect some basic metadata of the data going in and provide a standard naming convention for each file, add it all to a single geodatabase, and then ultimately convert those data into these SQL parse statements that can go into Dan Ponte's Survey data parsing system. Dan Ponte, so I'll talk a little more detail on each of these. And so this is a customization of a data management system by Dan Ponte. It's a system that Dan is very comfortable with. And it can be deployed as a web interface where Ali Pickering and Carla Rosa were pouring through the data and parsing each data point into the schema that the Clearinghouse has agreed upon. It's kind of a heads-up data view, and you can examine the data in map view and the photographs associated with the data, and it allows for adjustments to the location if necessary, and it preserves all original data. And then it has a lot of derivatives, including KMZ. So there are definitely room for improvement. All data was sent to us by email for the most part. And so I'm kind of listing a few things that I see as improvement. One being kind of take some lessons from maybe the Monte Cristo event where they were sharing a cloud storage, which isn't trivial for us. USGS has issues with public cloud storage. And then there's various improvements that we can I foresee along the way in terms of quality control. I'd like the Clearinghouse to help me review the schema within the data is collected in the GIS logging tool, and the big one is Dan's Servoy data system is really something that he's been using for many years, and it's not something that everyone is familiar with. So we need to have training to keep that alive because Dan is retired. So looking a little closer at the data logging tool that I generated, it's a Python toolbox that can be used in ArcGIS Desktop or ArcGIS Pro. I see this as a tool that would be used in a clearinghouse situation where people are bringing in data and we are logging data to a single geodatabase, or it could also be multiple geodatabases that we could eventually merge. It's a very simple tool, and it just collects some basic metadata as to the origin and data content. It converts it to a standard naming convention and in a single geodatabase, and then eventually exports it to Dan's system. Looking at it a little closer, this is the form that I've created that collects. So this would be someone processing the data that's been sent to them, or that is in a, say, Dropbox or a cloud storage, where you record some basic metadata. And then that data is converted to a single geodatabase as featured data sets organized by the institute that the person is related to, and it creates a related database showing the metadata and then all the feature classes. And then moving on to Dan Ponte's Servoy data management database for parsing data. This is all customized by Dan, and it has a HTML interface where Ali and Carla were able to access the database from home and go through all the different data sets that were provided, and Dan's scripting behind the scenes helped to better organize and parse out the data. And there was a number of error checks such that you can't put a value, say, over 360 degrees, or there's just a number of things that Dan has added into this system that allow for a cleaner interface and for higher accuracy parsing. So, for instance, parsing involved extracting data from the notes, unit conversions from, say, inches to centimeters, and ability to verify location accuracy of a point and associate photographs to observations. It was first used in Napa, and he retooled it for Ridgecrest. And the observations and photographs, oops, let me go back. It brings them all into a single database. And what we've obviously found is that the art collector schema equals much more rapid parsing, or those people that used our Excel files that had the same schema to translate their data into, that equals rapid parsing. And so basically we're just, while we're encouraging people to migrate towards our collector or something equivalent that has a more rigid database to speed up this process. the first priority of data release were those points that had fault and slip measurements, and eventually Dan will be releasing photographs and non-slip measurements as a data release. So some lessons that we've learned. Look, the warm bodies are in short supply, and we need to find more efficient ways of processing data. And I think really it comes down to more discipline on the field data collection effort in the field, perhaps more photograph discipline. More photos of a single feature are not better than one good photograph for turning this data around. Also, using our collector is definitely going to be encouraged, or something equivalent that has a disciplined, rigid schema. And we are finding that time between events equals a stale workforce, and we need to have more training exercises. It seems like we're always caught off guard. Data collected without the schema are slow, as I've said many times, and we just need to continue going over our scripts and try to make this more efficient. It's just time is of the essence. It's not easy to work on these tools, as we are all pretty well tasked out. And so it seems like we have quantum leaps for every earthquake that occurs. And this definitely was a good example of that. And then finally, as I said before, we need to really reconcile a central location for people to submit data, and then perhaps provide ways of better allowing people to update data. That's all I have for right now, and I say thank you.